Thank you everyone for joining us, and as Marcy said, if you do have questions, please enter those into the question box and we'll respond accordingly. To those questions that we don't have time to get to, we will respond in a follow-up email to answer all the questions as much as possible. This presentation is registered with ICC, as Marcy mentioned, and it is copyrighted through the American Wood Council. The learning objectives today will be to understand how the wood frame construction manual is referenced in the model codes. We'll understand the general layout of the wood frame construction manual, and then you'll hopefully understand the general provisions in the wood frame construction manual, and then finally we'll also go over new provisions from the 2001 to the 2012, so you'll get to know the 2012 changes. Now, also, the general outline of the presentation, so you can get an idea of how we're going to proceed through this session, is we'll go with a baseline about code references. How is the wood frame construction manual referenced in the codes? And then we'll go chapter by chapter, chapter 1, 2, and 3, on a discussion of the chapters, and so that you become familiar with the chapters and go over the changes in the 2012 version. Now Buddy will pick up during chapter 3, and then he'll get into some further information on the commentary to supplement, and then also future information on how the wood frame construction manual will expand its applications. And then we'll go into other resources. Now, as Marcy mentioned, we are using an interesting tool, which is the polling tool, to get more interaction from the audience, and in no way does this affect your ability to receive your certificate of completion. But the first poll will be, let me find this on there, that will ask the audience, it's a very easy one, is to get an idea of what the audience makeup is, and hopefully you'll get this. We'll launch this poll, and you can click on your computer, and the first question is, what is your area of expertise? And I see that people are quickly responding. We'll just wait till we get a few areas of responding. Looks like heavy engineering. Come on, builders, let's put in your input, and architects. Okay, we have a good feel for who is attending, so we'll close the poll. We're at 82% of the audience has responded, and we'll close it, so quickly. Okay, what happened? Uh-oh. I closed the poll and now something happened. Okay, I'm going to have to escape out of this. Sorry about this. Something happened when I closed the poll. So I am sharing the poll right now, and for some reason, let me go back into it. Are you seeing the poll? 71% of the audience is engineering, and 9% is architects, and 16% is code officials, and 2% is builders, and then we have 2% of other. So the next question has to do with getting a little bit more feedback on, let's see, I think I shared that. Next one has to do with background on which of the use of the wood frame construction manual, just to give an audience. So we'd like to know which of the following statements is true. I've used the 2001 wood frame construction manual. I've used the 2012 wood frame construction manual. Or you've never used it at all, and you've never even heard of the wood frame construction manual. So we're getting some responses, good responses. 50% responding have used it, 2001, only about 12%, 2012, 39% have never used it. Well, that's good, because hopefully this will give you some information and some tools that will be made available using this. 7% have never heard of it. Okay, so let's close the poll, and we'll share the results. Hopefully you see the results now. I'm not seeing it, but hopefully you are. And you can see that 49% have used the 2001 wood frame construction manual. Only about 12% have used the 2012, 39 have never used it, and 7% have used it. So that gives us a good idea. So thank you very much for responding to our poll. It gives us a good idea of the makeup of the audience, and we'll now proceed to the presentation. So how is the wood frame construction manual adopted within the codes? In the 2001 wood frame construction manual, it was adopted under the 2003, 2009, and 2006 IBC and IRC codes. Now the 2012 is the most recent standard on the wood frame construction manual, and it is adopted under the 2012 IRC and IBC, and we'll go over where it states this within the code on how it's actually adopted. First, starting off with the IRC, it is adopted under section R301.1.1 as an alternative to the provisions of the IRC to be used. You can use the wood frame construction manual.
Michelle,
yes.
This is Brian. Sorry to interrupt.
Yes.
Your slides are not showing up.
Oh, they aren't?
No.
Okay. Well, I'm glad you chimed in. You're not seeing it go forward?
We're actually not seeing anything.
Oh, really? Well, thank you for, I'm glad you didn't let me go through the whole webinar like that. Okay, because we had this problem. How about now? Are you seeing this now?
There it goes.
Well, that's strange because I was seeing it. And, okay,
well,
thank you for chiming in. Okay, sorry about that, audience. So we'll back up. A little technical difficulty. So the wood frame construction manual is adopted under the IRC 2012. And here's a specific, hopefully you can see this slide now, the specific code reference where it's adopted as an alternate to the IRC. Also for wind design, when we have buildings that are required to have wind design or where the wind speeds are greater than or equal to 110 miles per hour, you can also use the wood frame construction manual. Now note that it states that you can use a wood frame construction manual or ICC 600, which is a relatively new standard that's adopted in the IRC. And within this is for residential construction in high wind areas. It does mention that if you're designing a wood building using the IC 600, then it needs to comply with the wood frame construction manual. So that's one reference. So for wind design, the wood frame construction manual is a great resource to go to for designing. Also, under the IBC, it's also referenced under Chapter 16 for wind loads, for those that are for residential applications. And then in the next slide I'll explain that a little more. But under Chapter 23, it's referenced as a standard. For those buildings that you're using the conventional construction, then the wood frame construction manual is referenced as a standard to be used under conventional construction as well. So I mentioned about using it for wind loads under the IBC, and this is the exact statement from the IBC code where it states as an alternative, well, first it says determining of wind loads, you can go to ASCE 7, but also it also says that you can, subjects to the limitation of 1601.1.1, you're allowed to use the ICC 600, which I mentioned previously, and then that's for residential R2 and R3 buildings. But it also states you can use a wood frame construction manual. Now the previous code referenced 2001, and now the current 2012 code references 2012. And this says within the limitations of 1601.1.1, that has to do with escarpments or hillside applications where you have some special requirements for that. But other than that, you're allowed to use the wood frame construction manual. And I'll go into that in a little bit regarding the ASCE 710 and some items related to that. But again, under the 2009 IBC, it referenced the 2001 wood frame construction manual. And then under the 2012 IBC, it references the 2012 wood frame construction manual. Now, what's handy about our website is if you go to our website, there's all these little icons that says what's changed. If you click on that icon, that'll provide you with a white paper, really quick white paper about what has changed from the previous editions. And that's true for our NDS documents or our wind and seismic provisions. This little icon will give you more in-depth information about the changes. Now, the wood frame construction manual is laid out in 3 different chapters. We'll start off with chapter 1, which is a general chapter, and then chapter 2 covers engineered design, and chapter 3 covers prescriptive design. So there are 2 methods of a design that can be used under the wood frame construction manual. And as I mentioned previously, I'll go through chapter 1 and chapter 2, and Buddy will pick up on chapter 3, rounding up. But the general layout of chapters 1 and chapters 2 is connections, then it gets into floor systems and wall systems and roof systems. And this is kind of a reverse of how we would design an actual building. Typically we would start from the roof and work our way down, but it's laid out this way to mirror the layout of the IRC, the International Residential Code. And then we have a supplement that's part of the wood frame construction manual and the commentary, which Buddy will give more information in his presentation. But first, starting off with general. And you may, if you have your wood frame construction manual, you may want to go through and follow along with this. It would be helpful. If not, it's not a problem. We are going to have the notes available after the presentation, or Brian is giving you links to the PDF of the presentation. But starting off with the wood frame construction manual, chapter 1 starts off with the general provisions for the entire manual, and it gives you tips on the limitations that are provided for this. As many of you are aware, we need to provide some boundaries or guidelines by which we design buildings, and the same is true as what we provide as guidelines for developing the manual. This provides you with an all-over building dimensions and then load assumptions that were used when creating the document. And then chapter 2 and chapter 3, when it breaks into engineered and prescriptive, there are also some additional load assumptions that are provided. And that's all in table 1 of each of the chapters. As I mentioned, well, as you noted in the previous, there are special limitations that are noted for the actual overall dimensions of the building, and they're repeated here. Mean roof height of 33 feet, 3 stories, and then the overall dimension of the building is 80 by 80. But one thing that is new to the 2012 wood frame construction manual is the incorporation of the design requirements in ASC 710. That is new. So now we're all up to speed with ASC 710. These are the parameters that we cover within the wood frame construction manual, which is 0 to 70 grounds snow load, and then 110 to 195 miles per hour wind speed. And then we also cover, and so I'll get into a little bit more detail about the wind speed, but we also cover seismic design categories A, B, C, and D. Now, D, some of you may not recognize this if you're only using IBC, but IRC uses these subcategories of D sub 0, 1, and 2. And the seismic design is based on the alternative simplified method in the ASC 7. So something to be aware of. So this is all new to the wood frame construction manual. Now also, just as a side note on where the background is on ASC 710 and some things that you might want to be aware of regarding the ASC 710 relative to ASCE 05 is the balanced and unbalanced loads. It does take into account the ground snow loads. Now that is not different from 7.5, ASC 7.5, because that was incorporated at ASC 7.5, but we just wanted to make you aware. It still takes into consideration unbalanced and balanced loads. So there's relatively unchanged values from the 7.5 to the 7.10. But this is a really helpful white paper link that if you're interested in finding out the background of what the change occurred in the 7.5 related to this unbalanced load. What happens is when the snow is on the roof, sometimes there can be a buildup of the snow on the ridge, which is higher than at the other areas of the roof because of snow drifts and everything. So this takes into account and gives an equivalent rectangular surcharge rather than a triangular surcharge. Just a little background. But if you want more information, that's a really free download white paper to give you more background on that. Now, the wood frame construction manual does not take into account sliding snow, because that is really load condition that is specific to a building, and we couldn't really provide that for all different types of buildings. So that is not in consideration. That will have to be approached or designed separately. Now, the seismic loads also have changed under ASC 710, and it's based on the new risk-based maps that are in the code, and which has been reduced along the New Madrid and Charleston, South Carolina area because of the information that has been researched on the areas. And then in some areas of California, some regions, you'll see an increase because of the research that has been done in those areas. California has been hit pretty hard with some of the isolated areas like Santa Barbara, where they've seen a big increase in seismic loads. But this is all based on the revised contours of the maps, the risk-based maps. And more side notes related to wind speed maps is, if you're using the code now, you would see that they are strength design based maps now that show higher wind speeds, but the overall effectiveness of the wind effective pressures remain about the same. If you want to get some detailed information on wind speeds, this ATC Council, ATC, the Applied Technology Council, has a calculator that will help determine the wind speeds. So again, new to the wood frame construction manual. But this shows you some information, background about what's happening in the hurricane areas, where the beige area shows you the ASCE 705 area, and then the red line delineates what the new contour lines are for ASC 7 for the hurricane-prone region. So you can see in some areas you're going to get a reduction in your wind speeds and overall pressure, whereas these will remain the same because the new contour maps have not changed. But that's where you're going to see some changes. Now, getting back to the wind speeds, this is important because there are some subtlety differences between IRC and IBC. The IRC did not adopt ASCE 710, and they're still on the allowable stress design. This is the basic wind speeds under ASCE 7, and if you did a calculation, the equivalent wind speed would be 110 under the ultimate or the strength design, and then 116, so accordingly 110 would be 142. So that gives you the actual mathematical increase if you're going to the ASCE 710. However, and then if you want some more information on the change that occurred, there's a really good white paper by Phil Line and Bill Colburn that's available on our website that gives you wind provisions and effects on wood design construction and how it affects it based on the changes. But looking at this wind map, this is the new wind maps in ASCE 710, and you can see there's an increase. What used to be 85 is now 110, and most of the country used to be 90 miles per hour, but now it's 115 because, again, it's based on the strength design. So using those maps, if we go back, we look at IRC, which is based on allowable stress design, we have 85, 90, and 10. However, using the wind maps under ASCE 710, you can see that, and again, these are the equivalents, so you have 100, the equivalent is 129, but the maps in ASCE 7 is 100, shows 130 contour or 140 or 150. So there's not a direct correlation between the maps in ASCE 710 and ASCE 7.5. So you'll have to work with the building officials if you want to use the maps in AAC 710 and figure out which contour you will use, because at 160 or 130 miles per hour, the ultimate would be 168, but would you use 170 or would you use 160? Again, you'll have to work with the building official on how you do, what values you want to use. But the one thing to remember is that Wood Frame Construction Manual is based on ASCE 710. Hopefully this hasn't confused you, and if you need more clarification, you can contact us and we can hopefully explain it. But that white paper will explain it in more depth. Now, the wind exposures categories are incorporated within the maps, and for the hurricane-prone areas, it does incorporate, again, the exposure D in those hurricane coastal areas. One thing to be aware of. Getting back to Wood Frame Construction Manual and Chapter 1, we're going on all the basic lateral loads and the dead loads and all of that. One thing that is new to Wood Frame Construction Manual is a clarification of what is not covered in the Wood Frame Construction Manual, and that is those ancillary structures such as decks, balconies, carports, and porches. Those are not covered in the wood frame construction areas, so you'll have to look at another resource for designing those. For example, DCA 6 for designing the deck document, which is a free download from the American Wood website and covers deck design. Now, we'll do a poll. This is our third poll. And again, your certificate of completion is not dependent on your answer for the poll. But the question is, let's see, hopefully this will be successful, is, does the Wood Frame Construction Manual include both engineered and prescriptive design? And the answer is either true or false. Does the Wood Frame Construction Manual include both engineered design and prescriptive design? And we are getting some really good responses from the audience. Good participation, actually excellent participation. And we're at about 75. I'm just going to close it right now for sake of time, but the majority of the audience has participated. I'm closing it, and I'm going to share the results. And the results are 89% of the audience that responded said it's true, and 11% said it's false. Well, the answer is, let me go to this, is the Engineered Wood Construction Manual includes both engineered design and prescriptive design. So again, your certificate does not depend on the answer, but the response is true. Yes, it includes both engineered design and prescriptive design. Now we'll get into Chapter 2, and we'll cover the engineered portion of the Wood Frame Construction Manual. As I mentioned in Chapter 1, it begins with a table that gives you the overall assumptions that were used to create the engineered portion. I'm giving the limitations of that chapter. And it is also assumed that when engineering a building, we want to provide a complete load path. I mean, it's not, that's just total engineering practice. Yes. Oh, the slides are not showing again. Let me try and do this again. Thanks for the message. That poll must trigger that from, okay. Okay, now is it showing? Someone respond. Are you seeing? Yes, okay, thank you. Okay, it's that poll. So there's the table. We're going to have to work out those technical difficulties. Sorry about that, audience. Okay, so the Wood Frame Construction Manual, there's an engineered table that shows you the engineered design limitations. And backing up, when we design a building, we want to make sure that there's a continuous load path through the building, meaning that there's continuity created by the connections from the point of origin. It all needs to go down to the soil. So there's a lot of different load paths throughout the building. We don't want to rely on, many of you may have heard of that term skyhook. There is no such thing as, there is a skyhook. If you want in your imagination, but not in real life in buildings. We want to follow that continuous load path. Whether it's vertical loads, we want to make sure all that load gets transferred throughout the building all the way to the foundation, whether it's a building on piles or whether it's a building on foundation. It all has to be complete, and that's the assumption with creating the Chapter 2. Also for lateral loads, this is very important, and this is something that's not always intuitive to engineers or architects or builders, is that lateral load, because we don't always deal with it, but it has to be a complete load path from the point of origin to the foundation. And again, raised pile building or one that's on slab on grade or a raised floor on grade. Now, in the engineered, it also provides you with parameters on what the assumptions are when engineering a building. If you have a floor that has an offset, a vertical offset, that offset is limited to D, which is the depth of the joist. Can't be anything greater than that. For horizontal offsets, say a shear wall, the maximum that it can be from the shear wall below is 4 feet maximum. And of course, throughout both of these situations, there needs to be that complete load path of engineering the transition of loads to make sure it's going to the point of resistance. Now, connections. I wanted to go over a little bit about the vocabulary that's used throughout the presentation when it's related to connections, because I saw when Buddy and I were going through it, maybe this is an East Coast or a West Coast thing, but the whole vocabulary of out of plane, in plane, and but there's 4 categories that I wanted to go over. One is when we're dealing with connections and we're talking about lateral, there's a section on lateral. We're talking about out of plane, not in plane, but out of plane connections. So here's a building, and this is something that I changed in the notes. I'll change this in the PDF because it showed an incorrect figure. But when we're talking about lateral, the lateral is out of plane. So anything out of plane, a connection that connects this wall or to the resisting diaphragm, is out of plane. That's lateral. Now we're talking about shear. We're talking about shear, that's in plane. So whatever it is in the plane of the wall is shear. And then if we're talking about uplift, when uplift, we're talking about the rafters being lifted up or the whole wall being lifted up, the resistance of uplift due to wind loads on the building. And then if we're talking about overturning, we're talking about the overturning of a shear wall. So it's the overturning of the shear wall in plane in the shear wall. And this is to provide some dimensionality when we're reading through a document. You don't always get that dimensionality of which direction we're talking about. So this, to be clear, and this is explained in these sections, overturning is the overturning of the shear wall, and uplift is the uplift related to wind, vertical uplift. Because sometimes if you're talking about seismic, you could say the uplift at the end of the shear wall, but that's not what we're talking about. Hopefully that clarifies it. If you need more information, you can go to those sections and get more information. Okay, also included in the engineered portion of this is, and this is the great thing about this manual, is how it will tabulate the loads for you so you don't have to go through all the calculations to find out what load you need to design a certain connection. This wood frame construction manual will provide that for you. So you just go through a table and say you're designing a thrust connection or you have a collar tie or a rafter tie. This will provide you with the output. Say if you have 20 pounds per square foot, your pitch of your roof is 6 and 12, and your span of your roof is 30 or 20 feet, the actual load that you need to design for is 300 pounds. So pounds per linear foot, sorry, on that roof. So that's the connection load that you will need to design. It does that calculation for you. In addition, uplift connections. If you're doing an uplift on a building, this will provide you. You just go to this tabulated load and you pull out the 140 miles per hour. Your roof span is 36 feet. It'll give you 321 uplift pounds per linear foot. That's what the connection needs to design for. So it does all the calculations for you, and it's all tabulated. And this is an example. It gives you examples of uplift connections on what needs to be provided. For the uplift of the roof, you need to give you an example of an uplift connection. And Buddy will get into this more in his presentation on where it'll provide you with the actual prescriptive nailing applications, how many nails you need for that. But this just gets into the actual loads. That's the engineered portion. And there's the strap example. It'll also provide you with the wind load sections, so you don't have to go through all the rigorous calculations in the zones. It gives you the actual wind loads for that building. And then lateral load, the wind loads for the diaphragms. I'm sorry, this table covers the diaphragms. It gives you those lateral loads. Again, making it quick shortcuts so you can just pull the values out of the table and then design your diaphragm accordingly. And then lastly, the seismic wind loads. Because there are so many different parameters for seismic loads, it does not give you the actual load, but it gives you the equations for calculating the seismic load. And then this is true for load-bearing walls. So for snow loads and live loads, it gives you the unit header or girder beam loads for that girder or beam in that line. So very handy tables to help. Okay, and now I'll hand it off to Buddy, who will be taking it from here.
Thank you, Michelle. So what we'll do from here on out is talk a little bit about the prescriptive section of the wood frame construction manual. And similar to what you saw in the earlier portions of the manual, there will be a table right up front in Chapter 3 that tells you whether or not you can use the prescriptive provisions. And a good example of that is here where we show the floor diaphragm aspect ratios. In Chapter 2, I believe it gives a specific aspect ratio of 4:1 or something like that. Here we've actually tabulated those floor diaphragm limits in tables 316B and C, so you'd have to check there to make sure that your structure is within those limits to be able to use Chapter 3. Another feature of the wood frame construction manual is if you exceed the limits of, say, the prescriptive section, it gives you the option to go back to the engineered section. Sorry about that. It does give you the option to go back to the engineered section and use that if you're within the limits of the engineered provisions, and then if you fall outside of the engineered provisions, it gives you the option to go out and use an NDS or wind and seismic standards, something like that. So what are prescriptive provisions? They provide very specific resistance requirements. So Michelle's done a great job sharing with you about the load provisions of the standards. So we, in Chapter 2, show you the snow loads, the wind loads, the seismic loads, and how those are going to be present on different parts of the structure. In Chapter 3, then, we give a solution to resist those loads, what's called a prescriptive solution. So we'll give the size of the header or the rafter or the floor joist or the number of connections needed to connect those building elements together to resist those shear, lateral, and uplift loads that she talked about as well. And so the table's a really handy approach to see if you're within those limits, to see if you can even use those prescriptive requirements. One of the things that's new to Chapter 3 is the shear wall offsets. In the 2001 wood frame construction manual, we made some statement to the effect that you could have a shear wall offset by this distance D as long as you maintain your load path. Well, that typically required an engineer or somebody to spec out something for that load path. So we added some detailing here, and then for the cantilever as well, to show how to maintain that load path and resist those overturning loads that would be present in the shear walls that are on offsets. So those are some of the new details you'll see. We always want to talk a little bit about rafter ties and collar ties because that tends to be a confusing issue to people. A collar tie is used to resist uplift here at the ridge. It keeps this ridge from opening up. And so this collar tie has nailing requirements to make sure that that ridge doesn't open up. A rafter tie, on the other hand, which would replace a ceiling joist if you're going to have a raised ceiling, is resisting thrust here at the heels of these rafters. And so we talk a little bit more in other chapters about those adjustments, because when you get that thrust at the heels, it's going to be much higher as you move your rafter tie higher up into the attic space here vertically, and so those loads increase. So you have these increase factors. So where if you were able to use, say, 4 nails here at the heel for a ceiling joist to resist that thrust, if you go up at least halfway into the vertical space, you see the factor here for 1/2 is a factor of 2, so that would require 8 nails instead of 4. And so we account for that in the tabulated values as well to make sure that you can maintain the load path down through the structure. Michelle talked about uplift, and so we tabulate uplift strap requirements to strap down the rafters or between floors, wall to wall. And so we'll show in a table like this the number of 8-penny common nails or 10D box nails that you need in each end of one of these straps for different wind speeds, for different framing spacing. Again, makes it real easy to pull value out of the table to see how you resist those uplift loads. Another new feature in the 2012 Wood Frame Construction Manual then shows how you can use wood structural panels to resist not only shear in your shear walls, but you can also combine to resist uplift and shear simultaneously with a wood structural panel. So this table 3.4b is real handy. You come into that table knowing what your shear wall requirements are, so you have to design your shear walls first with the applicable tables for shear wall design. I'll show a couple of those in a second. And then you come into this table and it shows you that if you increase your nail spacing to, say, 3 inches on center rather than 4 inches on center for your shear wall design, that for 120 mile per hour zone, for example, you can have a maximum roof span up to 24 feet. If you double up the row of nails in that shear wall along your top or bottom plate, then you see you can get even greater roof spans. So this table makes it real easy to come in and make your nail spacing a little denser to handle both uplift and shear, and that way get rid of all those metal straps that are required otherwise in the structure. So that's a new feature. The other new features to make sure that when we're maintaining that load path, that we line up our connectors so that we're not creating any cross-grain tension in these top plates. So if you're carrying your uplift loads through straps into the stud on the inside of the structure, then you're going to put this connector here on the inside so that they're lined up and don't put cross-grain bending on that top plate. Likewise, if you're using your sheathing to resist that uplift out here on the exterior, like we just showed you can do, then you're going to put your connector there. Again, it keeps from having cross-grain tension on those top plates. The shear walls, diaphragms, and shear connections in the Wood Frame Construction Manual have all been revised according to the newest standards, ASCE 710, the 2008 Wind and Seismic Standard, and the 2012 NDS. So all the tables are revised to accommodate that. We've simplified many of the tables for diaphragm and shear wall design, assuming a 10-foot eave to ridge height. The previous tables required that you tabulate the roof slopes, and you'd have to figure out that mean roof height. So we've just assumed a 10-foot eave to ridge height as sort of a default, and then we've got some footnotes and tables that adjust if your eave to ridge height is something different from that. We've also moved to a 10-foot wall height to the 2012 version as well, so that's new. Talk a little bit about segmented and perforated shear walls. There are actually 3 methods to design shear walls. There's those 2 that I mentioned, and then there's one called shear transfer around openings. We did not incorporate the shear transfer around openings into the wood frame construction manual. You'd still use the wind seismic standard for that. So what you'll see in the wood frame construction manual is still the segmented approach and the perforated approach. And sometimes we get questions of what that means. The segmented approach is the traditional approach where you're going to have hold downs around each one of your full height segments in the wall. So you see around all these window openings and door openings we've got hold downs. So that's the traditional segmented approach. The perforated approach allows you to fully sheathe this wall above and below openings and maybe have a little bit denser nail spacing or thicker sheathing or larger nails. And as a trade-off for stiffening up that wall, you get to move your hold downs out here to the corners. So you've eliminated, in this particular wall, 4 hold downs around these windows and doors on each wall. So the hold downs are much easier to locate in the corners, makes the construction process much simpler. To get through that process, we've got these tables that show you how to pick out wall lengths for, say, a segmented shear wall. And we're in exposure B right now, so let's say we've got a 40-foot wall length, and we're trying to figure out how much full height sheathing we need to sheathe that wall. We come over here to, say, 150 mile per hour wind, and we see we need 11.3 feet of shear wall. So we know that 12 feet will work. 3 4-foot panels would then be sufficient to meet the demand for what you need in that 150 mile per hour, assuming you only have a roof and a ceiling. And so that's a real easy table to use. Same for seismic. For the different seismic categories, we tabulate seismic categories A through D and different ground snow loads, 30, 50, and 70. And so, again, if you had a 36-foot building dimension and a seismic design category C, for example, you'd see that requires 15.5 feet, so 4 4-foot panels would work to carry the load through that seismic condition. And that's, it's a pretty good size snow load for that seismic condition. But again, this is only a roof and ceiling. You can go up to 3 stories with the tables in the wood frame construction manual. We give some pretty standard wall details. So the standard detail is going to be, say, a 7/16 wood structural panel with 8-penny common nails, 6-inch edge spacing, 1/2-inch gypsum, and 5-penny cooler nails in the gypsum. And so you see your adjustment factors are 1.0 for that particular wall. But let's say, for example, you went to a 2-sided shear wall. Instead of using gypsum on the inside, you decided to use 7/16 wood structural panel and have a 2-sided shear wall, wood structural panel shear wall. These adjustment factors then are what you would multiply what you get in the tables here that we showed a little bit earlier to come up with a new length requirement. And so obviously if you're adding sheathing to the inside, that's going to reduce the length of wall needed. And so you can see, for example, that 15 feet of sheathing we needed for seismic goes to about 7.5 feet if you did a 2-sided wall. To do the perforated shear wall approach then, a real easy table here to use accounts for the maximum unrestrained opening height. So you see we've got some openings here for different walls, H/3 all the way up to a full height opening in the wall. And then we are going to determine the percent of full height sheathing based on what we determined from our segmented shear wall. So let's say we've got 50% openings in our wall, and we've got a doorway in that wall. We're going to come over here to that 5H/6, which is our door, and we see that for a perforated shear wall, again back to, say, our seismic example, instead of 16 feet of wall, it's going to require about 40% more sheathing along that wall length. And so 16 feet times 1.4 then would give you the percent or the amount of full height sheathing you need to do a perforated shear wall. Again, you're going to increase the panels or nailing or whatever you need in that wall, but the trade-off is that you get to move your hold downs to the corner of the structure. Hold downs then are real easy to size because we account for the first panel in the wall picking up 100% of its capacity. So that's why we're able to have a really simple table here that just accounts for the first panel in the wall picking up 100% of its capacity. So you take the wall height and the panel capacity, and that allows you to determine a hold down for wind loads and for seismic loads. They're going to be different here because we are allowed to use gypsum for wind loads and not for seismic. So that's why your hold downs are going to vary. I think you're also allowed a 40% increase for wind loads, and so that's why your hold down capacities are going to be higher, because we're counting on higher capacity of those panels for wind loads. Exterior wall studs to resist out-of-plane wind loads. We allow you to design your studs, say in a gable end wall for let's say 120 mile per hour wind load, and that gable end wall you could go up to about 11 foot 6 inches for a number 3 or stud grade material with a 2x4. What's different in the 2012 edition is the old tables were based on an H/120 limit, but because of new provisions in the code and new finishes that are going to be on structures, we've added new tables to incorporate H/180, H/240, and H/360. New to the header tables is a distinction between raised headers and dropped headers. And so you're going to use the same approach for sizing your headers based on the number of roofs and floors that you're carrying through a structure. But we're going to account for the fact that in certain situations, like the one I'll show you here, if you've got a dropped header, the top edge of that header, say that's somewhere buried here in this above this garage door, this top edge is unsupported laterally. And so we've seen in the field some issues with headers buckling out of plane, in this case an inch of lateral deflection, because that top edge of the header is unbraced. And so we've gone to a new approach that will specifically spell out whether you're using a dropped or a raised header in your particular application. The wood frame construction manual supplement has been greatly simplified. We now, instead of duplicating tables from, say, the NDS supplement for design values and the NDS for connection values and wind seismic standard for all the shear wall and diaphragm values, we just reference each of these standards so you're always sure to get the latest information instead of this document maybe getting 1 or 2 cycles out of kilter with the newer standards. So those are all referenced in additional standards. We've also updated the commentary to make sure that those are that information is complete and in accordance with the new standards, the new loads. So the commentary is a very valuable tool if you want to find out the background information for how the wind loads from ASCE 7 are determined, or the seismic loads, or any assumptions related to the tables in the wood frame construction manual. You go to the commentary to find that information. So Michelle, I'm going to ask you to join me again. It looks like we've got another poll here to wrap up, and then we'll have some time for questions.
Okay. Okay, let's see. The last poll, and again, I know there were some questions coming in on whether or not this affects your ability to get a certificate, and this does not affect your ability to get a certificate. Okay, so this question has to do with which type of shear walls are included in the wood frame construction manual. Segmented shear wall, A. B is segmented and perforated shear walls, or C, segmented, perforated, and force transfer around opening shear walls. So the audience is voting. Again, here's the question. Which type of shear walls are included in the wood frame construction manual? A, segmented shear walls, B, segmented and perforated shear walls, or C, segmented, perforated, and force transfer round opening shear walls. And you can select one only. I don't know if it allows you to change your answer when you're doing this, but okay, we're at 81%. I'll go ahead and close the poll so we get a good feel, and we'll share it with you. So the answers are 2% of those who responded said segmented shear walls, and 77% said segmented and perforated shear walls, and 21% said segmented, perforated, and force transfer round openings. So,
and the correct answer is B, segmented and perforated. We mentioned earlier there is a force transfer around openings approach, but that's covered only in the wind and seismic standard. So answer B was correct. Segmented and perforated are covered in the wood frame construction manual. So let me give you a little bit more information about what's coming in the 2015 IBC. You might be interested to know that we are developing a 2015 version of the wood frame construction manual to pick up primarily the changes to southern pine design values. And that reminds me, if you do get the 2012 version of the wood frame construction manual, it will come with an addendum that includes all the changes to southern pine design values. If you're interested in seeing that now, you can go to our website and download that as well. Maybe Brian can put a link up for that as well here toward the end. But in the 2015 IBC, there's some changes that we're excited about because it gives the ability to use the wood frame construction manual in some non-res applications as a permitted resource. We'll go to the code change that actually was approved here in this last cycle that will be published later this year. But basically it creates, down here at the bottom, you see a brand new section in the 2015 IBC 2309. It says structural design in accordance with the wood frame construction manual should be permitted for buildings in any use group subject to the limitations of section 113 of the WFCM and load assumptions contained therein. So what that basically tells you, and a good example would be if you have a one-story slab-on-grade structure, the wind loads don't know whether they're hitting a commercial building or a residential structure. And so the wind loads are going to be similar if you've got a similar footprint of a building. Where you're going to run into difficulty for some of your non-res applications is the wood frame construction manual does only list floor loads up to 40 pounds per square foot live load. So a lot of your commercial buildings, corridors and floors are going to have 50, 60, 100 pound per square foot live load. So as soon as you get into multi-story structures, the usability of the wood frame construction manual is going to become a little bit more limited. But for your one-story slab on grade and some of those smaller commercial non-residential applications, this would be a tool that you could use in the future. So we're excited about that change. We do have a white paper on our website that provides a lot more information about these changes. Brian will probably throw some links there as well. And if not, you can download the PDF, and that'll give you the link where you can go download the changes that give you a lot more detail. If you're interested in a hard or a PDF copy of the wood frame construction manual, there are links available on our website for that as well. So Michelle, I think we've got time for a couple of questions. Why don't you tee a couple of those up, and we'll wrap up our session with a couple of Q&A.
Okay, this is great. Yes, we had a lot of questions come in, and for those questions that we are not able to respond, there'll be a follow-up question-answer document that will be sent to you via email. I believe Marcy will gather all that in a couple weeks. And so one of the questions that came out of the box was, let's see, we have a question about the application of wood frame construction manual under which code. And just a point of clarification, as we mentioned, it is adopted as a standard under both the IRC and the IBC. And as Buddy just explained, the use of it under non-residential construction will be expanded under the 2015 IBC.
Yeah, and Michelle, let me follow on to that, because one of the questions I saw was, what if we're still under the 2009 IRC? Can we use the 2012 wood frame construction manual? And our answer is typically to talk to your building official about that. Most jurisdictions will accept an ANSI standard, and the wood frame construction manual is an ANSI standard, and so you should be able to use the newer standard, the 2012, even if you're under an older code, but make sure you clarify that with your building official. And if you are a building official, you want to let your builders, engineers, architects know if you are going to permit that in your jurisdiction as an alternate as well.
That's a good question. Very good question. One more question is, does the wood frame construction manual have provisions for deck design? I know there's a lot of decks being designed out there and built, and as explained in the beginning of the presentation, it does not include deck provisions. However, AWC does have a document, DCA6, on our website that's available for a free download that does provide some guidelines for decks. And we'll also have a webinar on that in May 22nd, I believe. That's a complimentary registration that'll go over the new changes that occurred. Oh, great. It shows it up there on the bottom of the slide. One more quick question, maybe if you're open for it, buddy. We have one on a clarification. Could you further clarify the difference between a collar tie and a rafter tie?
Okay, so a collar tie is at usually in the upper third of the attic space and resists uplift loads. It keeps the ridge from opening up. A rafter tie is usually in the lower half of the attic space and resists thrust from the rafters due to gravity loads like snow or live load. So they function in two separate and distinct fashions, and you should not confuse the two or try and use one to accomplish the job of the other.
Great. Okay, great. I think we'll need to wrap it up, and we'll hand it off to Marcy to wrap things up. And Marcy, I think your microphone's on mute. Just some housekeeping items. Okay. Okay, Marcy, we're not able to hear you.
Tell you what, Michelle, let me go ahead and wrap it up. No, there you are. Okay, go ahead.
I was going to jump in.
Okay, sorry. All right, so just as a reminder, the presentation slides are here at this link, and that link is going to be sent to you in the email, so just make it nice and easy to click and get that those slides. And a reminder that in the email that's going to be coming to you, probably watch for that in the next hour. You'll be getting a survey link. I said before there are 9 questions. I think there are actually 8. Should only take you about 3 minutes to fill that out if you would for us. Also, information on your certificates of completion. Those will be coming in about 2 weeks, but in order to receive your certificate of completion, you must have been present for 90% of today's presentation. That was 54 minutes. So in order to receive your certificate, that's ICC credit. So, and if you were watching today with more than one attendee, like in a conference room with several of you, make sure to fill out a form, and Brian's been sending out the link for that, or a printable form. Make sure we get those, and then I can fill that out and get your certificates to you. Let's see, more information about AWC educational events. Send us an email at education@awc.org. Check out our website at www.awc.org. 2 new webinars coming up, one in May, one in June. The new Prescriptive Residential Wood Deck Construction Guide webinar on May 22nd. The brand new AWC web-based calculators and other resources webinar in June, or on June 24th. And if you're more interested in a more in-depth look at the WFCM, check out the AWC and Virginia Tech collaborative workshop, Prescriptive and Engineering Design per the 2012 WFCM. That's the weekend, or I'm not even sure it's a weekend, sorry, September 24th through the 26th. So thank you for joining us, and I think that's it.